This is a video about percentage error. This is a video about percentage error. I'm uncertain of my singing ability. Anyhow, let's get on with this walkthrough on percentage error calculations for A-level biology. Let's get to the mark. Looking at calculating a percentage error using two different instruments combined. Okay, this is for A-level biology. Let's get into it. So in test one, the student used a measuring cylinder to measure 15 centimeters, that's the measurement, from a beaker. The measuring cylinder gives a volume that has an uncertainty of plus or minus 1 centimeter cube. She used a graduated syringe to measure 5 centimeters. So that's a second measurement using a different piece of equipment. So we have a measuring cylinder and graduated syringe. The graduated syringe gives a volume with an uncertainty of 0.5 centimeter, plus or minus. She mixed these volumes of liquid to do a biochemical test, calculate the percentage area for the measurements used to obtain the full 20 centimeter cube mixture of the solution from the beaker and the Benedict solution show you're working. We need to treat them as two separate, then add them together. So for our measuring cylinder, we had an uncertainty of 1. We're going to divide that by the measurement. So the percentage error is 1 over 15 times 100. So we can do that now, 1 over 15 times 100, to work out the percentage error of the measuring cylinder, or we can combine it with the percentage error of the graduated syringe. Now, the graduated syringe has an uncertainty of 0.5, and the measurement taken was 5 centimeters. So we're going to do, don't need the C there, we do 0.5 over 5. We can add these together if we like, and then we can times 100, and that's going to give us our answer. Dead easy. So if you do that, you get an answer of like 16.66 recurring. You could round that up to 16.67, but there's a whole range up to 17% they give you. And there we go, just a quick little video. Sharing's caring, hit the like, punch up the bell, subscribe. 3.5, give the uncertainty associated with taking a measurement using a ruler with 1 millimeter graduations. Calculate the percentage error for making a measurement of 4 millimeters with the ruler. Right, why don't you pause the video, have a go. Okay, I'm going to go through it because there's a little nuance to this, which they have in biology. They don't do this so much in chemistry, but uncertainty, the smallest division divided by 2, that's dead easy, right? Aha. We have a little issue here. We're using a ruler. So when you take a measurement with a ruler, you're going to look at 0 millimeters and then you're going to go up. Oh, it's 25 millimeters long. You're going to, or 5 millimeters long. You're going to look up to another number. So you're actually got uncertainty in two places on the ruler. It's the same if you use a thermometer. Whereas if you're weighing something on a weighing balance or a weighing scale, whatever you call it, a mass balance, whatever, you're just going to get one number. So you're just looking at one number. There's only one level of uncertainty. Here, we've got to multiply our uncertainty by 2 once we work it out to get the total uncertainty. So whenever you take a measurement with like a thermometer or a ruler, you are looking at 2 different points, and you're looking, so there is uncertainty at each point. Okay, and so there we go. Yeah, I've over-explained that. You get the idea. So we want to do the smallest division. What was the smallest division? It told us the ruler had 1 millimeter graduation. So 1 millimeter was the smallest. We want to divide that by 2, and we're going to get 0.5. So 0.5 is the uncertainty, but the total uncertainty is times 2 is 1. Now we're going to work out percentage error. Okay, I lost my train of thought. My daughter was banging on about Octonauts and asking me to put it, whatever the episode with the swordfish on. I'm not really sure what she was on about, but I just had to run off and sort that out. So we're looking at percentage error, folks, and you've got to know the percentage error equation off by heart. The percentage error is your uncertainty, which we calculated in the first calculation, divided by the measurement times 100. So in this case, they've told us you're using the ruler to measure 4 millimeters. We know the uncertainty was 1, the total uncertainty, because in a ruler you double the uncertainty. So it's 1 divided by 4 times 100. The answer is 25% for the percentage error. And there we go. That will get you the marks. Okay, guys, looking at a percentage uncertainty question here. It's a multiple choice, 2.2 on the paper 3, 2023 2022 AQA A-level biology. Let's get into it. So we've been asked calculate the percentage uncertainty in the measurement of trial 1 in table 3. I've highlighted the relevant data in purple here. How you calculate uncertainty is by taking the smallest measurement on the equipment and dividing by 2. Now they're using a millimeter. Well, they're using a meter ruler, but the smallest measurements are millimeters. So 1 millimeter divided by 2 equals 0.5. So 0.5 is the uncertainty in this measurement. That's going to change later on. I'm going to show you why that's wrong. But first of all, bear with me. So now to calculate percentage uncertainty, we have a different calculation. You've got to do the uncertainty divided by the measurement in the result. So we know the uncertainty is 0.5 because we just calculated that. And the result was 79 for trial 1, table 3. So we do 0.5 divided by 79 millimeters times 100. And this equals 0. Well, rounded 0.633%. And we go, hey, it's the first answer. Actually, that was the wrong answer. A lot of students, when taking this exam, put that answer. It was a very common answer, but it's wrong, as we'll see now. So what we're going to see now is that actually we were using a ruler. Now it's different if we were weighing mass on a balance. There's only one measurement involved. But when you're measuring the distance on a ruler, there are 2 points of error. You've got the point at 79 millimeters, and then you've got the 0 millimeters. So there's actually two areas where we can get uncertainty. So we'll have uncertainty at 0 and uncertainty at 79. Therefore, we have to double the amount of uncertainty when using a ruler. So always remember that for your A-level biology. If you're measuring the uncertainty with a ruler, you need to calculate it, then double it. So instead of being 0.5, we've got 0.5 twice. So the uncertainty is actually 1 plus or minus 1 millimeter on any distance that we measure on the ruler, in which case the answer for this question is 1 divided by 79, which is uncertainty divided by the measurement times 100, and we get the percentage uncertainty, which we can round up. Yeah, we can round up to 1.27%. We actually get 1.2658%, but you round that up to 1.27%. I don't know why I've written 0.127 there. That's just a brain flip. All right, guys. Hope that helps. Let's get to the marks.
You're still here? It's over.